I'd like to take the time to expand a little bit more about vacuum in the food and packaging industry. Vacuum equipment represents a significant percentage of the energy that's used in packaging machines. And what I want to do today is take you through new ideas that are helping to save money and reduce cost of ownership. Operating a vacuum pump is an expensive thing. If there's better ways to do it, then this saves you a great deal of cost. I want to give my talk in two parts. I want to start off talking about vacuum solutions for multiple packaging machines. And then I also want to talk about vacuum solutions for individual packaging machines. Let's start off on the multiple packaging machines. As you can see here, you have a vacuum pump that's located inside each of these machines. This isn't always the best way of operating, and let's just explain why. Here's a packaging machine. You can see the vacuum pump tucked away underneath. And from the table there, you can see that the total cycle time is 8 seconds to make a package. But the time for the vacuum pump, when that is operating, it only needs 1.5 seconds. So there's a lot of time when the vacuum pump is sitting doing nothing. It's just idling. It's using energy, but it's not doing any useful work. So there has to be a better way to do this, because you've got a vacuum pump. If you're able to use a vacuum pump continuously, you'd only need a vacuum pump a fifth the size. So the best solution here is to start sharing the vacuum pump with other packaging machines. And what I'm going to talk about now is a concept called central vacuum systems. Here's a central vacuum, or a typical central vacuum system, quite a small one, so we can try to describe this. And what you've got here, sitting on top of the system, are just two vacuum pumps. And below it is a large tank, which is a buffer tank. We use these pumps to continually pump that tank. And from this tank, there's pipe work, which is going to each of the packaging systems. There's also a box there which is controlling the pressure, so that if the packaging systems stop, we don't need to maintain pumping, so we can save energy by switching the pumps off. But what we're able to do here is use only a few pumps to pump a large number of packaging systems. Another advantage that we get with this is we reduce maintenance costs, because instead of having a pump in each packaging system, we've just got a few pumps located on the tank. The total energy saving that you can get by doing this is up to 30%, and this can be very significant. Remember that if you're operating 24/7 for maybe 11 months a year, that's a lot of energy you're using. So this just shows a little bit more detail, or gives a picture of how we're moving from a vacuum pump for each packaging machine down to just maybe two pumps shared between a total of 6 packaging machines. If you look at some examples of this, how this can be done, the top picture is showing a meat slaughtering plant in France. You can see a large tank, and behind the tank is a row of vacuum pumps. This is the vacuum system. And you can see there's a pipe going upwards, and that is going to the floor above, to where all the packaging machines are. Down below is another example, where we've got 2 rotary vane pumps down at the right-hand side, and then we've got a tank, and just before the tank we've got a liquid separator to make sure that any water vapors that are coming towards the pumps are separated out and disposed of. And then there's pipe work again going up above to where the packaging machines are. Here's a second one where again, this is being used in a pork and poultry packaging plant. Two of the vacuum pumps are being used on the forming network. These are operating at a pressure of 100 to 150 millibar. And 6 pumps are being used on the welding network, which is operating at a pressure of 10 to 20 millibar. As you can see, there's pipe work going up above, but we're sharing the vacuum system across the whole packaging site. So if we just summarize on central vacuum systems, these are ideal where you've got many packaging machines and you want to use one common vacuum system. They give you a significant saving in energy, can save you up to 30% of your energy cost, and they save maintenance cost. The vacuum pumps, the rotary vane type pumps, need their oil being changed, the oil has to be disposed. If you have less pumps, less maintenance. So again, further savings. So that's describing what you do if you've got multiple packaging systems. But now let's talk about ideas for individual packaging machines. Here's a typical layout of a thermoforming machine. You can see down at the bottom, we've got an oil-sealed rotary vane pump. Now, that's the pump that's located in the basement, and it's located there because it's generating a lot of heat, and you don't want that heat in the room. You then have a pipework which is going up towards the packaging machine, and this pipework could be 60 meters long. And then in the machine itself, you'd have located a root type pump which is boosted, creating a lower pressure. It's giving a boost, and it's necessary to have this located very close to where you want to pump. If you try to move the booster down into the basement, then the size of the pipework you need gets bigger. This is one of the strange things with vacuum. As the pressure goes down, you need a bigger pipe, so the cost goes up. The cost of that pipework can be significant, and if you take 60 meters of pipework, stainless steel pipework, this could be 6,000 euros investment cost. And in this situation, we've got 2 vacuum pumps. So we've got the maintenance costs of 2 vacuum pumps, and we've also got the power costs of 2 vacuum pumps. Where the next generation is going is to start looking at dry vacuum pumps. These have changed a lot over the years, now have matured into a product which is very quiet with very low vibration. You hardly know they're running. They're also very cool running. They are water cooled, and if you want to put these in an air-conditioned environment close to where the packaging machine is, then there's very low heat loss into the atmosphere. They also have a much lower maintenance compared to a rotary vane pump. There's no oil to change, there's no oil to dispose of, there's no belts to change, so the maintenance costs for these pumps come down. They're also very energy efficient, and I'll show you in a minute the energy savings you can get from choosing a dry vacuum pump. In addition, these are compact and flexible, and let me show you this in the next slide. Here we have a packaging machine, and we've put a dry vacuum pump underneath it where the roots pump would normally sit. So we've eliminated the foreline, or the pipeline going to the basement, and we are connecting directly into the side inlet port on the vacuum pump. So we have an inlet, total height of the vacuum pump is 600 millimeters. This allows you to slide it right under the machine. And because it is quiet and low vibration, you don't know it's there. And because it's water cooled, there's no heat coming into the room. So what benefits do we get by taking a dry pump and putting it directly into the packaging machine? The first thing we got was a better performance. So the pumping speed was improved by 20%, which is allows you to increase the processing rate. The energy saving, compared to what I showed, that gives you a 4 kilowatt less power requirements, which is a 35% saving in power. It saves on installation because you do not need a four-line, so the pipe work going to the pump in the basement is eliminated. And you don't need a pump room. You don't need the basement. You can get rid of this now. Most people have the basement, so it's not so easy to get rid of. But in total, if you look at the cost of ownership, this drops by 36%, which is a significant amount of money. If we just look at those energy savings, at the top we've got the typical layout of an existing system where you have a roots pump, which is typically using 9 kilowatts, and you have, a rotary vane pump using 9 kilowatts, and a roots pump using typically 2 kilowatts. But because these are installed with bigger motors for when they're pumping down, you have to install 22.5 kilowatts of power into that facility. Down below, when you have a dry pump and you put the dry pump underneath the packaging machine, we only consume 7 kilowatts and we have to install 11 kilowatts of power. Now that's an installation cost which is much lower. It's going to be half the cost of having to install 22.5 kilowatts. So assuming that we're running this system 7 days a week, 24 hours operation, 11 months of the year, and assuming 8 euro cents per hour, then the saving here is over 2,500 euros per annum. If we then start to include the cost of maintenance into this, you can see from this chart the cost of maintenance for a dry pump is much lower because you're changing only a very small amount of oil once a year, and the disposal cost is much lower. When we look at the overhaul costs, because the dry pump doesn't need an overhaul so often, again, working it out per year, then it's cheaper per year. So if you look at the total cost of ownership savings, you can achieve about 3,000 euros per year saving. There is, obviously the dry pump costs a little bit more to buy, but you don't need the extra pipe work going to the basement. And if you look at a typical payback, you'd be expecting to get a payback after about 3 years. So if we just summarize about individual packaging machines, with the change in technology from the wet rotary vane pumps to the dry pumps, you're now able to locate the pump at the machine where you have low noise, low vibration, low heat output, and it's compact. You can eliminate the pipe work going to the basement, which is an installation cost, and you also eliminate the need for the booster pump. And when I showed you those energy savings, those were all ignored. They were just comparing a wet pump to a dry pump, and we were ignoring the booster pump, but the booster pump is an extra cost which you're going to save. So switching to a dry pump, this has the benefit that it gives you a lower cost of ownership due to the fact that it's an energy efficient solution. Okay, thank you very much for your time.